Now we'll move on to the microstructure module of PravaH, which is based on Monte Carlo Potts algorithm that is used for the analysis of grain evolution, grain misorientation, Euler angles, etc. So I have already given the name of my model and created it, and it is already saved in my systems directory. Now as I'll click on microstructure, it will open this window before us. On the left, you can see these buttons that are settings, save all, run solver, launch console, show results, save and terminate, and analyze microstructure. So when I'll click on settings, we'll start the simulation setup. Here, the user can choose the respective alloy by this drop down menu and can create a new alloy. You need to upload the scanning pattern here. And you can visualize your scan pattern and can check scan speed. In the computational settings, you can adjust accuracy, performance, data saving frequency, and the number of CPU processors. So I'll adjust my accuracy to 30 and the data saving frequency also 30. I'll use 20 number of CPU processors and then I'll save it and check on terminal. The values are saved. It will show the lattice size and the right interval. I'll click on back and save all. The values are saved and then I'll click on run solver. The terminal says modeling grain morphology evolution using modified MC Potts model. This button, Launch Console, is provided to enable the user to see the progress of the simulation in between. So I have clicked on Launch Console and it shows the simulation is completed 1.7%. To visualize the simulation results, I click on Show Results and here you can see the grain evolution. Now I'll reload the files by selecting Find New Files. This action will load all the available results. Users can have the flexibility to utilize all the available ParaView tools to visualize the result data. Now if I click on Clip and select the Z normal and choose my plane, and then apply, you can clearly visualize the grain evolution. After completion of the simulation process, the microstructure can be analyzed by clicking on Analyze Microstructure button. The Analyze Microstructure window contains three sections. The first is the input section that requires input regarding the minimum number of consecutive cells required for considering it to be a grain. The angular chord length distribution can be plotted by providing input from the user regarding the location of the cut planes. These values, cut x, cut y, cut z, are the values that you enter at which point you want to cut the respective planes to get the angular chord length distribution corresponding to the planes x, y, and z. So I'll click on Calculate CLD, and the terminal will show extracting microstructure data, and it will start calculating the grain chords for plane X, Y, and Z. So it shows done plotting angular chord length distribution. The grain size can also be calculated by clicking on Calculate Grain Size button, and the grain size will be plotted on a bar chart. So the terminal says collecting and analyzing grains with grain ID. And this is the grain size distribution with statistics. It gives value such as mean, standard deviation, skewness, kurtosis. So this is how you can analyze melt pool dimensions and microstructure grain evolution using macroscale and microstructure modules of AM PravaH. Thank you.